Alternative definition, remind me what it is. F prime of A equals what? The limit
as x approaches
A,
a, and then f of x minus f of a is over x minus a.
yes. So, if I'm, giving you some of those weird problems, wonder if a square root does better. I know, like, if I give you f of x equals x cubed plus 2, and I want you to find f prime of 2, for instance, using the alternative definition, then we say the limit as x approaches a, what's our a value? 2 of f of x, which is just x cubed plus 2, correct? Minus f of a. Now, f of 2 is just 2 cubed plus 2. 8 plus 2 is 10 over x minus 2. Everybody with me so far? And what is 2 minus 10? Negative 8. And then we can go, instead of having to FOIL out or do the x plus h quantity cubed in the other definition, what can we do to factor x cubed minus 8? The cubed root song. What do we do? Cubed roots, and you put them down. Ignore those. Square the first, change the sign, multiply them together, and square the last. That's the way you do it if you want to do it fast. So now we can cancel those out, right? And now the 2 is plug-inable, correct? Because we've gotten rid of the 0 that shows up in the numerator and denominator. What's 2 squared? 4. Plus 2 times 2, also plus another 4, 12. So we got f prime of 2. Hey, could we take that extra step and write the equation of the tangent line?
Yes.
Yes, we could. Because can I plug in a 2? Oh, I've already plugged it in. What is it? So we got the point, 210, and we got the slope, 12. How do we take that extra step? Minus y1 equals slope x minus x1. Beautiful, beautiful. How do we know what the x is approaching? It is whatever is in that a value. Oh, sorry. It is whatever, if I tell you find f prime of 2, or the derivative at x equals 2, that is the a value, right? Let's do one more example, and I'll just get y'all to do a couple of those. F of x equals 2 over x. And for whatever reason, this book always uses C. I'm sorry. First time I taught it, the first 5-6 years I taught calculus, that book always used A's. So I'm stuck on A's. But it says use the alternative form of the derivative to find the derivative at x equals c. So in other words, we're looking for f prime of 5, correct? So our limit formula will be the limit as x approaches what? 5 of f of x, which is just rewrite the 2 over x, minus f of 5. Is that just 2 over 5? All over x minus 5. Just straight from the formula, right? And now our same, little bitty problems show up. What do we do when we have those fractions within fractions? Fancy form of 1. We fully embrace the fancy form of 1, and we do a bunch of alliteration. What fancy form of 1 are we using? X and 5. 5 times x, x times 5. Makes no difference, right? Distribute, what do we get? 5 left over times 2 would be minus. That one, the 5s are gone, so is that minus 2x? And just like in the regular definition, what do I say never to do in the denominator? Never distribute. It will get us into trouble. Not real trouble, but it will make you undistribute again, right? What do you see as common in that top? Take out a 2, but I'm going to suggest a negative 2, right? And then you'll have an x minus 5, and there it goes. The offending term is gone. The thing that creates the 0, right? And so we're ready to replace our x with the 5, right? I don't know why I changed a negative 2 on top to a negative 5. 5 times 5, though, is, got it. There's our f prime of 5. And not that it would be pretty, but we could write the equation of the tangent line. What's the y value? 2 over 5, 2/5. So y minus y1, slope x minus x1. Plug it into the original always. To find the y value, plug the value you're looking for, the derivative, into the original. So if I gave you a couple of those to add into your practice, the only one that the other kids struggled with was this absolute value one under a square root. That is ridiculous, so I'm not doing it. So we have already discussed moving on to what I would entitle, oops, I'll stop this video.